what we'll do now is talk about how a linked list works when you try to insert data in that linked list. I'll illustrate the problem first, and then let's see if anyone can do, or we'll do it on our own. So the way we build a linked list, first we add the first node, let's say 10, then its next is null, then we add another node which gets added to the head, let's say 15, and this gets connected over here. Then we add another node, always gets added at the head, so let's say 12 gets connected like this, and let's say one more node, let's say 7. Now at this moment, if you see a list like this, who is the head? This guy is the head. Okay. And tail, if you want, is this guy. But we are not working with the tail yet. We are only concentrating on the head. So the head points here, and that's how the data goes. Okay. Now the next scenario is, or the next question we have to do is, suppose I tell you that I want you to add a node at the second position in the list. So we'll call this the 0th position, we'll call this the first position, this the second and third. So let's say I want to insert something, let's say tentatively, at the second position. That means I want to, let's say, insert 9 here. I want to create a 9 here, something like this, instead of this. Let me draw a dot here. So we want to create a node in between at the second position. Second position means, okay, now how am I going to create a node at position 2? The trick here is, which I think you should understand, if I have to create a node at the second position to take this guy's place, then I have to create a node here, somewhere, connect the previous node to this node, to the node at whose position I want to insert. So I have to bring this guy in between. So if I have to bring this guy in between, and the position he has to come in is 2, then I have to anchor myself at position 1. If only I stop at position 1, can I create somebody at position 2? This is important to understand, and many people will not understand this. See, if on the other hand, if I want to insert something at position 3, then I need to anchor myself at position 2, create a new node, and then shift this guy's pointer, and then make this guy point to this guy. So this is what we have to do. So we always have to position ourselves or anchor ourselves at one position earlier than the position we want to insert. So tentatively speaking, if I want to insert something at position n, I have to anchor myself at position n minus 1. So if n is 2, then I have to go till 1 and stop. If I want to insert at position 1, I have to stop at position 0. I have to anchor myself at position 0 and then see if I can insert something in between. I cannot come here and try to replace that position, it won't work. I have to come one step earlier so that I can engage the pointers the way I want them to be. If I want to insert at position 0, that is a special case. That means it's like add node, which we have been doing. What add node we have been doing, that is like position 0, right? So that we will handle it maybe separately. So if I say I want to insert at position n, we have established that we have to anchor ourselves at position n minus 1. And how do you anchor yourself at position n minus 1? You have to move forward n minus 1 times. Now, how will you, suppose you are at head, how will you reach position 1? You will reach position 1 by moving forward 1 time. you have to move forward one time, then you will reach position 1. If you move forward 2 times, you will reach position 2. So that is obvious from here. So if I have to come here from the head, I have to move 1 position forward. If I have to come here from the head, I have to move 2 positions forward. So if you want me to position at n, I have to move forward n minus 1 time. Let me write that. If we want to insert at n, we need to reach n minus 1th node, and to reach n minus 1th node, you have to move forward n minus 1 times. Okay. So that is what you have to do. So this is what is going to be our logic for writing a function insert node. We are going to insert node is going to be called with 2 parameters. What are the 2 parameters? As usual, the head of the list. Head of the list we assume is a global variable, so let's not use it. So we have to say at what position we want to insert and what data do we want to insert. So let's assume that is what we want to create and create such a function. So let's go back to the code. Okay, we'll give you the code we wrote last time. All these exercises are kind of connected. So you will need the previous code to write the next code. So we'll have to make available to you the previous code. So practice lab 46. I am going to write that function. It's going to return a new head pointer if needed. Okay. Let me start writing that function. It is going to return a new head pointer. So what should its return type be? It may change the head because you may insert in the beginning. So what should its return type be? What should be the return type of a function which can change the head? What? What will it be? Struct node star. Array, what is a head pointer? Head pointer is a struct node star, no? It can change the head pointer. Struct node star. We are treating it as a global, but it doesn't matter. So struct node star, insert node. Insert node will take 2 parameters. The position at which to insert and then the data to be inserted. Int pos, I meant position, okay? And what data do you want to insert? Int d, okay? Does everybody agree with the signature of the function? That is called the prototype. Yes, no? Some of you may think struct node start need not be given, just insert and all. Anyway, head is a available variable, so you need not give it. That's fine. That point is correct. No semicolon. Let's start. Now you are going to think with me and we are going to write. So the special case of the situation is if the position I want to insert is 0. That's a special case, no? That means you want to bring some node and put it right in the beginning. So what can I do? Very good. I can simply do add node because add node does exactly the same, which is a function I have written. Correct? No, yes. Add node already I have written, which will add to the first node. So in a way, add node is a special case of insert, where you are inserting in the first position. Agreed? So why don't I do that? So I'll check if pos equal 0, then insert node becomes add node. So let's see how we call add node. Go down. Add node has exactly the same return type and it can add an element in the beginning. So now help me with this, go up. Okay, now what will I say? Remember, I need to return the head pointer in case it's changed. It will change in this case. What will I say? Return. Good. Return whatever add node gives me. return add node. Now, what will I say? D. Return add node D. Correct? Over. Because inserting at position 0 is nothing but what add node is doing. Bringing a node and putting it right in the beginning of the list, giving a new head pointer and returning it back. Correct? So, yeah. Now, in all other cases, the head node won't change. Okay, so we'll return the head node later. Else. Else means what? He's asking us to insert at a position other than the first position, other than the head. Good. So now our logic comes in for insert node. Okay. So if you are inserting at position pos, we just concluded, we have to reach a position pos minus 1. And how do I reach a position pos minus 1? I move forward pos minus 1 times. Correct? If you move forward, if you are asked to position at 1 because you want to insert at 2, how many times do you have to move forward to reach 1? One time? Arey, you are at 0, Baba. You are always at head. So we always start with head. So you have to move forward that many number of times, no? To reach n minus 1th position. Remember we discussed, if you have to insert something, you have to come one node before that position and then you can splice that thing in. Okay? If you reach that position, you can't alter that position. You have to go one position before and then rearrange the pointer so that you are positioning it accordingly. So what will I do? I'll create a temp pointer, struct node star temp, and I'll initialize it to the head, whatever is the current head pointer, which we are maintaining in a global variable outside main. So we'll say temp equal to head. Head is always available because it's a global variable. Okay, so I am positioned at head. Now, can you tell me what my next line is going to be? Okay, what should my loop be? How many times do I have to move forward? Pos minus 1. How do I move forward pos minus 1 times? I create a variable I equal to 0 and say while I less than pos minus 1, keep moving forward. That many times I have to move forward, no? Okay. So let's create that variable int I. You can create variables in a loop anytime. Int I. You don't have to go right to the beginning and do. You can write it inside because you need it here only. Semicolon. Make it equal to 0. So I'll move forward that many number of times while I less than pos minus 1, while I less than pos minus 1, what should I say? How do I move forward? Very good. Temp equal to temp next. That is how I will move forward, no? Temp moves forward. So, temp equal to temp next. Now, please, you need to understand it. Please don't just blindly type it. What we are doing is, we are saying struct node star temp is equal to head. So, we are first putting temp equal to head. We are positioning temp to head. Then we are saying some I equal to 0. Then, I have to move forward that many number of times. How many number of times? Pos minus 1 times. So that I will be positioned at pos minus 1. I am at 0. So, what will I say? While I less than pos minus 1, I will keep moving forward. Temp is equal to temp next and I equal to I plus 1. Would this logic work? Just think, no? If I have to position myself at node 3, I am at 0 because I have to insert at node 4. So I have to position at node 3. How do I move to node 3? I am at 0. So I have to move forward how many times? 3 times. Correct? 0 to 1, 1 to 2, 2 to 3. correct? 3 times. Unless I move forward that pos minus 1 times, I will not reach pos minus 1 if you are starting at 0. So now I have reached pos minus 1. That means temp, where is temp? Temp is just one node, temp is pointing to one node before the position I want to insert, correct? Now temp's next, whatever temp is now, next should be the new node that I am going to create. So now temp is positioned correctly. Let's come out of the loop. Temp is beautifully positioned, correct? Then once temp is beautifully positioned, what do I have to do? I have to now create a new node, correct? And make temp point to that node, and that node point to whatever temp was pointing to next. Yes, no, you have to think with me. See, let's go back. See, this is a list. Let's say I want to insert, this is my pos. Currently, I am here, my temp is here, and pos is here. So I want to insert at this position, means this guy has to go forward. You can't move things forward. So what you have to do? Now I am here. I have positioned at myself at pos minus 1. This is pos minus 1. Now I have to create a new node. Okay, this is a new node. Put the data in that node. Then I have to reorient the pointers accordingly. So this pointer and this pointer have to be reoriented. Okay, and this automatically will go because this guy's next will point here instead of here. So this is how this will have to be organized. So in order to get this organized, I am right now here. The situation is I am here at pos minus 1. And I now will have to produce this node. So in order to create a new node, what do I have to do?
First, store the temporary next value.
No, that I will do anyway. Now just to produce a new node, what do I have to do? I have to do a malloc. Without malloc, I can't create a new node. A new node has to enter the game, means first memory has to be allocated for that node. Automatically it won't come, no? So let's go back to the programming. Yeah. So what will I do now? I will say, now we'll say struct node star nptr. I'm just creating a pointer, nptr, semicolon. Okay. I'm just declaring nptr as a pointer. Okay. Now can I do it there? No. I'm not in the beginning of any loop. So I'll take it from line 22 and put it to the beginning of the loop. I can do it here. Okay. Now let me create the node here. nptr is equal to, what will I say? I want to allocate a fresh node. So we know how to do that. nptr is equal to struct node star malloc size of struct node malloc. Malloc's parameter is size of the node. Size of struct node. That's it, semicolon. Okay. So I got a nptr allocated. Now, whenever you allocate a new node, though it is not needed or it is needed, the good thing to do is what? Initialize the data. Okay. Now I am assuming that will not. The right thing to do, as somebody said, is we have to see whether nptr is null or not. But we'll pretend that we have enough memory. Okay? Not a good thing to do, but I don't want to cloud the code unnecessarily. So we'll say nptr is equal to, nptr's, we've got nptr allocated. nptr's next, whenever you create a new node, please remember, nptr's next equal to null. Please make it a habit whenever you do this. And nptr's data is equal to D. So nptr is allocated correctly. And we are positioned, we have created a new node. So now we have these two chaps. We have temp, we have NPTR, and now the business of connecting has to start. So going back to our picture, okay, so to give you, those of you who are very slow, this is NPTR. The new node that we have created is NPTR. Right now its next is null, its next is null, and its data is whatever you want to insert. So if this is 10, 12 and 15, and if you want to insert 14, this is what it is. So NPTR has the data, its next is null, and we don't even have this guy pointing to here. Right now, temp is here, temp's next is this guy, where I want to insert, that means this guy has to come here and this guy has to move ahead. So this 14 has to be brought in, NPTR is pointing to 14. So the reality of our situation currently is this. So let me just rub this. Yeah. So we are kind of here. Okay. Yeah. And right now this is pointing here. So now what should we do? Okay. What should be the code that we should write? We should perhaps say what should be NPTR's next? After the modification, what is NPTR's next going to be? It is going to be temp's next. Should be NPTR's next. Does everyone agree? What is currently temp's next should become NPTR's next, because NPTR is going to come into the picture in between. Should become NPTR's next. That is one line of code. So let's write it. NPTR's next should become temp's next, or temp's next should become NPTR's next. Okay. You should assign temp next to NPTR next. Everybody agrees with that? And so now what will happen because of that? Okay, let me. Okay, what will happen because of that is, this is what will happen. This guy's next will point to 50. Okay, but is that enough? No. Now what should be done? What is the next line of code I have to write? Temp's next should be equal to NPTR. So this should be cut. That will automatically get cut if you say temp's next is equal to NPTR. That is what we need to do to bring this guy in. So again I will rub this, and now we have to do this. So this line 2 will do this, and line 1 will do this. Okay, sorry, this is 1. Okay. So this will achieve that. NPTR's next is equal to temp's next, and temp's next afterwards. The sequence is very important. First, don't tamper temp's next. That should become NPTR's next first, and then temp's next should be set to NPTR. If you do it ulta, you will get different answer, completely haywire. Okay, so this needs to happen, and let's do it and then look through the code again. Okay, so let's do this. So we'll say NPTR's next is equal to temp's next, and last line will be temp's next is equal to NPTR itself. That's it. So let me now, and then eventually, no, we need to still return head. In this scenario, we will not change the head, but we will still always have to give, as a result of insert or add node, we have to give the head pointer whether it's changed or not. In the first case, when it was 0, we changed it. Now we don't. So we still have to return it, however. So it is return head. That's it. So let's walk through the code again. Yeah, let's go back. Go for. Okay, I am going to walk through the code again very carefully. Remember, we have to. Why are we calling insert node? We are calling insert node because we want to insert a node at a specific position. Then only insert node is called. Okay. Insert node, I am going through it very slow now because after this you are going to write delete node. Insert node, if you understand well, delete node you can write in a jiffy. Okay. The process is the same. So struct node star insert node. Now why am I doing this? Because I am expecting that the head pointer will change. Though traditionally you don't have to do this. You can change the head pointer without any problem. You don't have to return it. But it's convention and practice to do that. So it is expected to return the new head after the insertion is done. So struct node star insert node, two parameters. At what position do you want to insert? What is the data that you want to insert? Two parameters. First we are checking if position equals 0. That means somebody wants to come in at the beginning of the list. That is called position 0. For that you don't have to write any logic. You can do our add node because add node has been written to add nodes to the head of the list. This is what he is seeking to do. So we figured that out and said if pos equals 0, return simply add node D, and whatever add node D will give you the new head that you are going to return. So answer is solved there itself if position happens to be 0. Else if position is anything other than 0, then you have to do this else part. So in else what we are doing? We are creating a temporary pointer, making it point to the current head. Then what are we doing? We are saying int I equal to 0, and we are also creating another temporary pointer or another pointer nptr. Both of them are going to be used. Then we know that if I have to insert a node at a position n, I have to position myself at n minus 1. And in order to position myself at n minus 1, starting from head, I have to move myself forward n minus 1 times. Otherwise, I will not position myself at n minus 1 or pos minus 1. So, while I less than pos minus 1, I will use the temp which is currently pointing to the head to crawl forward one time, every time. So, at the end of the while loop, and I will increment I. At the end of the while loop, my temp will be very nicely positioned at one position prior to where I want to insert, which is beautifully positioned. That is where I want to position. So I position myself. Now I am prepared to create this new guy, new node. So to do that, there is a standard piece of logic which is on line 23, 24, 25, which is first create the node, then by default as a standard practice, make next equal to null and data equal to whatever data that we want to create. Those are standard steps, but the important steps are on line 26 and 27. So I have an NPTR whose current next is null and which has the data, which is the good part. Now how do I bring this NPTR into the chain? I have to bring him into the chain. To bring him into the chain, temp is pointing to one position before where I want to bring him. So as I showed in the picture. Can we go back to the picture? So this is the picture. So right now temp is pointing to 15. That 12 is pointing to 15. So temp is on 12. Where I want to insert is that node 15, where I want to bring in that data, and I am at 12. And NPTR is that 14 which we have created. Right now there is no connect. So what will I have to do? Those two lines of code, NPTR's next, which as of now is null, should become temp's next. Temp's next leads to the node number 15. So now 14 should lead to 15. So I am bringing in temp's and NPTR's next should take the value of temp's next. Whatever temp's next is as of now should be taken by NPTR's next. The next thing I need to do is now temp's next should be altered. Now it should not lead to 15, it should lead to 14 where NPTR is. So temp's next I have assigned it to NPTR and then the circuit is complete. Next already got assigned to earlier temp's next. Okay, so that's what will do the trick. Now, if the trick is working, then I should do a couple of inserts and check whether they are working or not. So that is what we'll do in the main code. So let's travel to the main code and see. Yeah.
Sir, add node is not declared before, but we are using it.
That's a good problem. Yeah. So add node is getting used by insert node. Actually, add node should be before insert node. Otherwise, you'll have problems. There is another way of doing it, but for the time being, because insert node uses add node, whatever I am using should be already there, seen by the compiler. What is a simple thing to do? Yank add node and put it before insert node. So what I mean by doing that is, go down, good catch. So add node is on line 68. So pick it up entirely, you can pick it up if you want. You should, unless I use prototypes and all. After line 6. Are you with me? Do you know why we did that? We did that because insert node needs add node. There is a clever way of not doing, this is one way of doing it. There is a clever way of doing it which is called creating a prototype. Okay? I'll do that in one shot later. All these prototypes and all I'll introduce. But right now, if you just put that before, that's fine. Okay, now we'll go to main and make changes. We'll build the list. This will display the list as it is. Okay, come down. This will sum the data. I think that's too much of code. Let's remove from line 99. Okay, we're just removing that code. Okay. So I don't know what the list is as of now. Okay, the list as of now, draw the list as it exists now. So as of now, the list is 25, 40, 34, am I right? 11, 22, no? So head of the list is 22, 11, 40, 25. So this is 0, position 1, 2, 3, 4. Okay, so let's insert something like 38 at position 3. At position 3, let us insert 38. So then the list will be 22, 11, 34, 38, 40 and 25. This will how my list will look like afterwards, after I have done the insertion. I am inserting at position 3. So wherever 40 is, so 40 will be pushed ahead and 38 will come here like this. So this is so I'll have to move up to position 2 because I am inserting at position 3, then do the appropriate circus and I'll get connected. So let's give it a shot of inserting at position 3. So, okay, here we go. Okay, so we'll say head, new head. If it changes, it won't change, but let's put it. Head is equal to, because it returns a node pointer, right? Head equal to, if it is changing, head equal to insert node, first comes data, no? What are the parameters? First comes position. First comes position. So 3, comma, 38. Does everybody understand this? I am inserting at position 3 a node with a value 38. I am doing that. So now, after I have inserted, to check whether my insert is working correctly or not, I'll have to display the list again and see whether it's coming in the right order. Now you have the code right there for line 95 to 98. Just copy that code. 95 to 98, just copy the code and put it here. So once you put the code here, then you will be able to see the data, the new list. Okay. So we will say old list and then new list. Printf new list \n. Yeah. New list. That is new list after the insertion of the node. Okay. Let's check whether it works or not. We have an error. Head declaration is above. Add node needs a head, so that has gone below. Line 83. Take line 83 and put it at the top after the declaration of the structure. Okay. Because add node uses head and we need head. So let's check. Okay. So the list looks like this. Okay. I think we didn't print new list. After that we didn't put a backslash. So that's why the 22 is coming there, but that can be small thing. So earlier list is 22, 11, 34, 40, 25. New list is 22, 11, 34. You see 38 has come in the way we want it to come in. So 38, 40, 25. That's the way the new list has come in. Can you make that out? No, yes. Okay, we will check again. Okay, well, let's try to insert at boundary conditions at position 0. There also it should work. Then it should work at the end also. Okay. So let's try this out. Okay. So we will say instead of saying 038, okay, we'll say instead of saying 338, we'll say 038, where we want to insert at position 0. Okay. So let's check whether this works. So we are creating a list, but now the new node 38 should come at position 0. Yeah, it's fine. You can see there the first list was 22, 11, 34, 40, 25. The new list which we are creating comes at 38, 22. The node came in the beginning. Did you see that? No, yes. We just changed the position and we said where should it insert. Okay. Now we'll do one more thing. We'll try to insert at the last position. What is the last position in our original list? So if I try to insert at position 4, that's the last position. Okay. There are only 0 to 4 positions, correct? Last position is 4. If I insert at 4, the last guy will be moved ahead. Okay. So, okay. So we'll say insert node at position 4. Okay. At position 4. Okay. Let's try this. Okay. So 0, 1, 2, 3, 4. We said 4. We can say 5 also. Can we say 5? Okay. You can try that. Is it working for 5? Yeah. So you can try 5 also. Then it will go to the end of the list. Here it is not end of the list. It is one before. At position 4 we are trying to insert. 0, 1, 2, 3, 4. So the fifth guy goes ahead. Okay. So that's why he came in between. So if you insert at 5, that will be the end of the list. Okay. Because there is no such position. Yeah, it's coming well at 38, right? Because whatever it is, its next is becoming NPTR's next, which will be null, and temp's next will be set to NPTR. So fine. You have to get a grip of insert node. It requires a little more of reading of the code, understanding it. It's not that difficult to get it. I'll give you this code. So I'll give you practice lab 47. Take this code from us, and then I'll tell you what we'll do next. Read that code so that you have the same code that we are having, because some of you can't even type well. Okay, are you able to see under 47, please? Please refresh your screen, check 47. Practice lab 47. You would have got our code. Okay. Look at the insert code on your screen. See the way we have done insert. Because I am going to ask you to do something after this. This is the insert node. Takes care of various scenarios. Okay, let's pretend that our list is this. Okay. And I now will ask you to do delete at a particular position. So delete a node, I am not asking for a value. I am saying delete a node at a particular position, or delete a particular node whose position I am going to give you. So let's call this delete node, and I'll give you the position of that node. Let's say I say 4. So what do I have to do? The node at position 4 should go away. Now who is at position 4 in the list? This is position 1, 2, 3, 4, 5. If this is the list, this is at position 4. Now I don't know, our list may be different from this because now we inserted at end, so we'll get it back. But if this is the list, we have to we have to delete a node at position 4, that is here. Again, in order to delete a node, what do you have to do? Where should you position yourself first? Temp. See, if you have to get rid of this guy, what do you have to do? You have to position one step before, no? Same way like in insert. So you have to position yourself here. If you position yourself here, that is one position before. Then what you have to do? This guy's next is right now here. His next should become his next. This is temp. So temp's next should be set to temp's next. Would I be right in that? In the simple condition that I have to delete this guy, this is allowed to be said. Temp's next should be equal to, this is temp, I will position one position earlier, like we did just now. Of course, there is no need to create a new node and all, because this is not insert node. I have to say temp's next, this guy's next, should become this guy's next. But if I do this blindly, I have a risk. Now I have lost a pointer to this. I'll get, this is a very tricky problem. This is how, if you write code only like this, what will happen? After this, what will happen? This guy will point here. That's not a problem. But what is, if I just write this line, what is going to be my problem? I'll have a 40 will also be pointing to that. That's not a problem because nobody is pointing to 40. But what is the problem? What I have not done? Good. So, if I just write this line, my code will work momentarily, but this is called bad code. I mean, if you write just that line, it is not bad. Why is it bad code? Because I have not deallocated the memory for 40. I should have got rid of 40 of memory also, no? So before I set temps next to that temps next, the earlier temp next, which is pointing to 40, I have to preserve it somewhere. I should create another pointer called, let's call it dptr. Instead of node pointer, new pointer, let's call it dptr. So I should say struct node star dptr is equal to temps next. Before this line, I have to take temps next, because that temps next is pointing to 40. I have to take that 40 pointer somewhere and keep it with me. How do I get it? I'll say struct node star dptr is equal to temps next before I do this line. Because after I do this line, temps next is last. It is now pointing to that node after 40. 40's pointer will be lost, so I have to preserve that pointer, and then I have to free it. So that care I have to take. So it is like saying, before I do this, okay, before I do this line, I have to say struct struct node star dptr is equal to temps next, the old temps next. So this dptr will be a pointer to 40. So dptr will point to 40. Then anyway I am updating temps next. So either here or here, wherever, I can do it here also. I have to say free dptr. Okay, I can do it afterwards also, it doesn't matter. But this is like releasing the memory for this 40. This has to go. Unless I make it go, it won't go. And that is called freeing. For that I need a pointer to it so that I can free it. Okay. So I need to do that. Then I can say free dptr. So this step is very crucial. I have to take the old pointer, keep it in here, and then free it. Now this is okay if I am deleting a node whose pos is not 0. What will I have to do if its pos is 0? I want to get rid of the node whose pos is 0. That I should handle it separately. So let me draw it again. Suppose my node that I want to delete is at position 0. So let's pretend this is 22, 11 and whatever, 34, whatever. So I want to delete this guy. I'm not drawing the whole list. So I want to delete this guy. So if I want to get rid of this guy, he is the head, remember? So when will that happen? When pos is 0. So I have to write this condition. If pos is 0, what I have to do? I have to update my head to heads next, and old head I have to delete or free. Okay. So I have to handle this condition. In this case, the head will change and head will become heads next, and the current head will have to be cut off. Cut off means it has to be deleted. So all those things I'll have to write the code for doing that in my delete node. Okay. So now I know will get a little heavy for you at point, but that's how it works, and I didn't make linked list. Okay. So now we are going to write step by step code for doing this. Let us write it after 7. You can write it actually, because we don't need add node. It doesn't matter. We'll write here. Next line. So this delete node will also return a head pointer if needed. So let's make it the return type. So struct node star delete node del node. Parameter to it is the position int pos at the position at which we want to delete. Okay. Now anybody feels confident to write it on their own? I've already described how to write delete. Remember, you have to take care of the condition. If pos is 0, what to do? If pos is not 0, what to do? Pos is not 0, lot of the code is similar to insert node. Why? Because there also you have to position one node before and then do a deletion of that node at a particular position. So, do you want me to write it, or are you going to write it? 5 minutes. Okay. Right now it is 10:55. Okay, I'll give you time till 11:05. Okay, 11:05 we'll start writing and finish it. Okay, we'll start. Now I'll go step by step. We'll delete a node in a list. Okay, let's go step by step. So as usual, whenever we write code, we look at the rare or boundary conditions, or sometimes we call it terminating conditions. In this case, suppose I ask you to delete a node at the beginning only. So position is 0. What code will you write? So if pos equal to 0, then what will I do? Then my head will have to change, but again I have to preserve the old head so that I can free it. So I'll still say, let's declare a temporary pointer nevertheless at the top itself. So it can be used all through. After that bracket, just say one struct node start temp so that we can use it. We don't have to create it again and again. Start temp. We're just creating a pointer which points right now nowhere. So if pos is 0, then what will I do? I'll say temp is equal to head. You know why I'm doing that? So that I can discard temp later. Temp is equal to head, and head is equal to head of next. That is going to be the actual head. Pos is 0 means the head of the list is getting knocked off. So the new head is going to be whatever this head is, his next, and temp is preserving that. And head is equal to heads next. And then, yeah, can you tell me what is the next line going to be after 14? Yeah. So I have to say free temp. Some of you are getting it good. Free temp, I have to release that memory. Head has already moved ahead. So whatever the earlier head was pointing to, that is in temp. So temp I am freeing, and I have to say return, because the function needs a return head. Always return the head, whether you change it or you don't. In this case, you will change it. Okay? Okay. So we got, where are you? So we got pos equal to 0. We handled the situation for pos equal to 0. Else, pos is not 0. That means I am deleting somewhere in the list. What should be my technique be? I should position myself before it. So I have to position myself at pos minus 1. We know the trick to position pos minus 1. We start with temp equal to head and move forward pos minus 1 times to get to such that we are positioned at pos minus 1. So we'll repeat the same trick. So we'll say, we'll move forward pos minus 1 times. So we'll say int I equal to 0. Temp is equal to head to start with. Yeah, and then we are going to move forward pos minus 1 times. No, while I is less than pos minus 1 times, we are going to move ahead. So we are going to say temp equals temps next. This is a code we wrote earlier also. This is standard code to position yourself one step before. This is needed all the time, most of the time in linked list. So we are saying temp equal to temps next, right? So now, and I equal to I plus 1. Obviously, we need to increment I because we have to count that many positions. Yeah, we are now correctly positioned. Our next node has to be removed. Because our next node has to be removed, so when I am now at temp, my next node is temps next. Correct? No, yes. That I have to preserve it somewhere because I have to free it. Okay? So now I'll declare one more pointer here, okay, to preserve the next guy. So I'll say struct node. I'll declare it whatever name I want to give. Struct node star dptr. I'm creating a new pointer, dptr. Okay. Then I'm going to say, after this positioning, now I'm getting ready to delete. So who is going to go out? Temps next is going to go out. Am I right? Temp is one step before. temps next is the guy who needs to go out. That I am going to put in dptr. The pointer to that node, I am going to put in dptr. So I am going to say dptr is equal to temps next. So this guy has to go, okay, temps next. Then, am I right? Then, if this guy has to go, that's one part of the story, I have taken a pointer to him. Now temp is what? The previous guy, pos minus 1 guy is temp. So what is the line I have to write now, the magic line? Temps next. Temps next. Temp is one position before. His next should become the next guy's next, because the next guy is going to go away. So temps next should become temps next next. Now some of you hopefully will get confused, and I hope you get confused because we want you to get confused, okay? Some of you are smart, will understand line 29. What we are doing is, we are putting his next as the next guy's next, so that the next guy can go away. So the only guy now pointing to temps next is dptr, because now current temps next has moved to point to his next neighbor. So temps next is equal to temps next next. This is a very interesting line. And can you tell me what is line 30? Free dptr. Here he can go, because my next guy can go. And as is convention, we always return the head pointer. Return head. End of the game. I'll walk through this again. Okay, we are walking through this again. So struct node star del node int pos. We are creating a temporary pointer which points right now nowhere. Now we are handling the special case where pos equal to 0. So if pos equal to 0, the first guy has to go, head has to go, and new head has to be created. So temp is equal to head. Head is equal to heads next. Current heads next is going to be the new head. Okay. And free temp, here he can go away and return head. End of the matter. Head has changed, right? Because the guy at the head has gone. That's why head is equal to heads next. We have done that. Else. Else means I want to delete not in the beginning, but somewhere in the list. So just like we did in case of insert node, we have to move forward and position ourselves at a point before the position of deletion. And to do that, we have to crawl forward pos minus 1 times. So that is taking care of that. So int I equal to 0. Struct node star dptr, we are just creating a pointer. Temp, we are initializing it to head. And then we are saying, while I less than pos minus 1, that is, we have to move pos minus 1 steps ahead to reach pos minus 1. Remember, you are starting at 0. So temp is equal to temp next, I is equal to I plus 1 till you reach pos minus 1. You have reached pos minus 1. Now you are at pos minus 1. Who is at pos minus 1? Temp is at pos minus 1. Who has to go away? The pos plus 1, pos guy has to go away. I am at pos minus 1. So what am I doing? The next guy's pointer, because I have to free him, I am putting him in dptr, because otherwise I will lose a pointer to him. So dptr is equal to temps next. Then I am saying, I am one position earlier. My next should be whoever is the next guy of the guy who is getting deleted. So temps next is equal to temps next next. My temps next is the guy at pos. His next is pos plus 1. So pos minus 1 should point to pos plus 1. That's the way we will get rid of pos. We want to get rid of pos position at that position. So pos minus 1's next should point to pos plus 1. That's the only way I'll get rid of. It's like a chain. If you have to take out a link in a chain, you just have to make the previous guy point to that link's next. So we are doing that in line 29. And because we have to get rid of the next guy at pos, we are saying free dptr. return head. Now if this works, then we should test it with various ways. So let's go down. This is printing the list as it is. Okay. Then, okay, let's see this list. This is the list right now. Printf list after deletion. Printf list after deletion, semicolon. Now head is equal to del node. Okay. Which node will delete? We'll delete node number 3, let's say. Some node 3, and then we'll print the list again. So you can copy that code from line 125 to 128. Okay. We are going to print the list. Okay, so 3 lists are going to be printed. List before insertion, list after insertion, list after deletion. So let's see how it goes for us. Okay. Let's see whether we are able to get it to work. Yeah. So forget the first list. Okay, let's focus on this. Look at the new list. The list was 22, 11. 22 was at position 0. 0 was 22. 1 was 11. 2 was 34. 3 was 40. And 4 was 25. 5 was 38. We said delete position 3. Okay. Just a minute. I will just write the positions next to it. So let me illustrate. The list before this was 22, 11, 34, 34, 40, 25, 38. This was the list. It had 6 elements. Then we had said pos equal to 3, you delete. So what we did, pos equal to 2, we positioned here. We connected this to this, and we deleted this guy. So after that, the list should look and is looking like 22, 11, 34, you see here, 34, 25, 38. So 40 has gone effectively out of the game. That is position 3. So that is what we wanted. The value at pos 3 should go out. So we were able to get rid of it. Now let's try pos 1 and then we can stop. Go to code. So pos 1, delete node, position 0. So the 11 should go. Okay. So let's run it again and check. Okay. 22 was at the head of the list. So 22 was knocked off, and you see it was 11, 34, 40, 25, 38. So it's working well, at least for beginning positions and in between position. My reading is it will work well nevertheless in any case. So now we'll give you this code. It's accessible at home. Go through this code. Unless you become extremely familiar with inserting node, adding node, deleting node, we can't do much with lists and you'll be left on your own. Because all the subsequent exercises we are doing are having stacks and queues which need lists. We are going to work on list. So take this couple of days and become familiar. So we are going to create this as code. They will put it in 48. So please look at code 48, study it entirely before you come to next session. So please read this whole code, 48 page, practice lab 48. So read practice lab 48 in detail, understand it, you will understand it. Take time and then come back. This question will be accessible at home.